Welcome again, ladies and gents. Today what we're going to start with is reviewing the limiting reactant problem from yesterday that I assigned. Remember, we learned yesterday that a limiting reactant means it's going to run out first in a reaction, meaning that reactant is going to get totally used up, and once it's used up, we can't make any more product. So like with the marshmallows and the s'mores yesterday, we ran out of marshmallows before we can make any more full s'mores. So when those marshmallows ran out, we couldn't make any more product. That happens in every chemical reaction, and how we figure out the limiting reactant is through using our stoichiometric calculations on our mole map. So the only difference between the calculations we were learning a couple of days ago and the limiting reactant calculations is you're going to have to do two different calculations. The reason you have to do two is because these problems are going to give you a mass of each reactant, and you're going to have to calculate how much product you can make with that reactant. So you can see here that I set up my problems where I solved for my N2 turning into NH3 and my H2 turning into NH3. And you can see that when you compare these two values, my N2 makes way less product than my H2. So what this tells me as a chemist is that this N2 is limiting because it's going to be all used up after 304 grams of our product has been made. So once this guy is all gone, our reaction can't go any further. I know that this is limiting because my H2 that I put in can make almost 3,000 grams of NH3, and this is a much bigger number than what my N2 gas can make. So when you're trying to identify what the limiting reactant is, you use your mole map to figure out how much of your product you can make. Whatever amount is lower, that is going to be the total amount you can make, that's the maximum amount, and the reactant you start with is going to be your limiting reactant because it's going to be all used up before the other piece. So what we're going to do today is we're going to take that idea of a limiting reactant and we're going to add one more concept in, something called percent yield. So there's two vocab words you need to know for you to calculate the percent yield. The first word is theoretical yield. The word theoretical comes from theory, and theoretical is defined as the amount of product that you would make when calculated from a given amount of reactant. And this word calculated is really important because what this tells us is that you used stoich. So you're going to use the mole map to calculate your theoretical yield. This is also what I call the perfect world amount. So your theoretical yield is what you should get in a perfect world. Because when we do our mole map calculations, we're calculating how much we should get if we do the lab perfect. So the theoretical yield is what you should get in theory. So this is always the number that you're trying to get. So this is our perfect world amount. The second term you need to know is something called the actual yield. The actual yield is going to be what you actually get when you're completing the experiment. And so what this means is you're actually getting the number by doing a lab. So your actual yield will be from your data. So this is going to be a number that you're going to get from your data table. It's not going to be anything calculated using the mole map. It's going to be a piece of data that you are actually getting while doing the experiment. So what we do is we use these two numbers to calculate the percent yield. So anytime you've ever calculated a percent on a test, you've calculated your percent yield for that test. Because the theoretical yield is the total number of points on the test. Because in a perfect world, I'm such a great teacher, you should all get 100% every single time. Yeah, right. But in a perfect world, that's what it should be. You should all get a perfect 100%. So that's your theoretical yield, the total points on the test. Your actual yield is the points you actually earn. It's the number that I give you. So to figure out your percent, you do your points over the total points and multiply by 100. In chemistry, we just use the numbers we get either from stoichiometry or from the data table. So you take your actual yield, which is going to be your data, and you put it over the theoretical yield, which is what you calculate, You divide those things and then multiply by 100%. What you get then is called your percent yield. So let's go ahead and look at what a problem like this might look like. So when you're looking at percent yield, sometimes it'll also be a limiting problem, and sometimes it will just be a regular stoic problem. I know this one is also a limiting problem because I have two masses. So the first part of this problem is going to be doing a regular limiting calculation. So how many grams of N2 are formed when 18.1 grams of NH3 react with 90.4 grams of CuO? So let's go ahead and let's organize our work around the equation. So I know my problem tells me I've got 18.1 grams of NH3, and I know it also tells me that I've got 90.4 grams of CuO. So the first calculation I'm going to do is I'm going to go ahead and I'm going to calculate how many grams of N2 I can make when my CuO reacts. The second calculation I'm going to do is I'm going to calculate how much N2 I can make if my NH3 reacts. Now you'll notice this guy isn't balanced, so we need to go and walk through that process. I have an odd number of H's here and an even number of H's here, so the first thing I'm going to do is by making that odd number even, I'm going to put a 2 in front. That now gives me 6 H's here, so I'm going to put a 3 in front of this to make it 6. So now my H's are balanced. I now have 3 O's, so I'm going to go ahead and put a 3 in front of here, so that makes my O's happy. I now have 3 Cu's, so I'm going to put a 3 in front of here. That makes my Cu's happy, and I have 2 N's here and 2 N's here, so I'm balanced. So the first thing I'm going to do is I'm going to see how much of my N2 gas I can make when my CuO reacts. So I'm going to start my calculation with my 90.4 grams of CuO, and because I'm starting in mass, the next thing I need to use is my molar mass. When I look at the periodic table, I'm going to add a Cu and an O together, and that's going to give me 79.545 grams. That's going to be equal to 1 mole of CuO. My grams cancel, and I'm left with moles of CuO. My next step is to use my mole ratio. So I look at my coefficients. I have a 3 in front of my CuO, so that tells me for every 3 moles of CuO, I can make 1 mole of N2. My moles of CuO cancel, and now I'm on to my last step, which is calculating my molar mass again. So I have my 1 mole of N2 that goes on the bottom, and I'm going to add 2 of my nitrogens together to get a mass of 28.014 grams of N2. I'm then going to punch that in my calculator to get an answer. So I'd multiply 90.4 times 28.014, and then I would divide by this guy in parentheses on the bottom. When you do that in your calculator, you get 10.6 grams of N2. We're now going to do the exact same thing, except we're going to go ahead and we're going to use our NH3 now. So our second calculation, we're going to start with our 18.1 grams of NH3. To get the molar mass of NH3, I'm going to add 1 N and 3 H's, and that gets me to a total of 17.0307 grams. And that's equal to every 1 mole. So I got myself to the mole 1 box, so now I want to get myself to the mole 2 box using my mole ratio. I look at my coefficient in front of NH3, that's 2. And then my coefficient in front of N2 is 1. So for every 2 moles of NH3, I can make 1 mole of N2. My NH3 cancels, and now I just copy this same step from before down here. So 1 mole of N2 is equal to 28.014 grams of N2. My moles of N2 cancel, I'm in grams of N2, and now I can get my answer. My answer for that would be, again, multiplying all the numbers on the top and dividing by the bottom in parentheses. And that would get me to an answer of 14.9 grams of N2. So when I'm comparing these two answers, I can see that my CuO gives me less product than my NH3 does. So my 10.6 grams of N2 is going to be the maximum amount that I can make. That's going to be my answer to my problem. And my CuO then is going to be my limiting reactant. So that means my NH3 is excess. So that's step one of this problem, is figuring out how much N2 you can actually make. So I run out of my CuO before I do my NH3, which means I can only make 10.6 grams of N2. I'm going to go ahead and erase this here, so I can do the second part of my problem. Sorry for the erasing time. All right, now that we've identified the limiting reactant, this now has a new name. This is our theoretical yield. So if we were to actually do this experiment in a lab and use 90.4 grams of CuO, in a perfect world, we'd be able to collect 10.6 grams of nitrogen. So I went to the back of the lab and I did this experiment, but when I didn't, I only got 6.63 grams. So I want to know what my percent yield was for this lab. Since this is the data that I actually got, this is my actual yield. So to calculate my percent yield, I do my actual over my theoretical and multiply by 100. So from my problem, my 6.63 is going to be my actual, my 10.6 is going to be my theoretical, and I'm going to multiply that by 100. When I give you these types of problems on your test next week, I have to give you the actual yield. I'm not going to have you do a lab in the middle of the test, so this number will always be provided. I will often ask you to calculate the theoretical yield. So just know that this number should be given to you. So when I punch this in my calculator, I get a percent yield of 62.5%, which isn't super awesome, but it's not super terrible either. So that would be my percent yield. Here's what I'd like you guys to go ahead and try next. We're going to go ahead and we're going to pause the video once I'm done talking. I would like you with one other person to start and work on this problem. What I'd like you guys to do is calculate the theoretical yield of the CH3OH and then calculate the percent yield if this is the number you actually got in a lab. I want you to go ahead and write it on any piece of scratch paper that you can find. The sub will have some for you. And please turn that in because I'll be looking at them and giving you feedback tomorrow in class. So work on this first. When you're done answering the problem, give your answer to the sub, and then he or she will give you your homework worksheet that's due on Monday, and they'll pre-lab for what we're doing in class tomorrow. Good luck, guys, and hit pause now, sub.